Article 240.5b2 permits tapping number 16 fixture wire to branch circuit conductors on a 20-amp circuit up to 100 feet from the point of connection. This allows for the connection of multiple light fixtures to a single branch circuit without exceeding the ampacity of the fixture wire. Here's an example installation to clarify the application of this code section. Firstly, consider a 20-amp circuit protected by a 20-amp breaker. Secondly, use number 16 TFFN fixture wire. Thirdly, connect multiple light fixtures to the number 16 fixture wire, spaced at intervals within the 100-foot limit. Now let's address some specific questions. Firstly, number 16 TFFN fixture wire is permitted to be tapped to branch circuit conductors protected by a 20-amp breaker, and the fixture wire is permitted to be extended 100 feet from the point of connection. The answer is true. Secondly, the permissible load on the number 16 fixture wire is a single luminaire only. The answer is false. The fixture wire can support multiple luminaires within the 100-foot limit and the ampacity of the wire. Thirdly, the number 16 fixture wires must be enclosed in an approved wiring method. The answer is true. This is not explicitly stated in the article, but it is assumed that proper wiring practices require protection and support for the fixture wires. To elaborate further, the National Electrical Code, or NEC, provides specific guidelines for the safe and effective use of electrical wiring and equipment. Article 240.5 focuses on the protection of conductors, specifically fixture wires, against overcurrent. The exception in 240.5b2 allows for the use of smaller gauge fixture wire, such as number 16, on a 20-amp circuit under certain conditions. Let's break down the key elements. Firstly, the tap refers to a connection point where the smaller gauge fixture wire is connected to the larger gauge branch circuit conductors. This is permitted because the fixture wire is only carrying the load of the connected luminaires, and its length is limited. Secondly, the term branch circuit conductors refers to the wires that run from the circuit breaker to the point of the tap. These conductors must be sized appropriately for the 20-amp circuit. Thirdly, the phrase 20-amp circuit means that the circuit is protected by a 20-amp circuit breaker. This breaker is designed to trip and interrupt the circuit if the current exceeds 20 amps, preventing overheating and potential fire hazards. Fourthly, number 16 fixture wire refers to the gauge and type of wire being used for the tap. Number 16 AWG, or American wire gauge, is a relatively small wire, and its ampacity is lower than that of the branch circuit conductors. TFFN stands for thermoplastic flexible fixture wire nylon. It's a type of wire commonly used for internal wiring of light fixtures and appliances. Fifthly, up to 100 feet from the point of connection is a critical limitation. The length of the number 16 fixture wire run cannot exceed 100 feet. This is to ensure that the voltage drop along the wire remains within acceptable limits and that the wire does not overheat. Now, let's consider the ampacity of number 16 fixture wire. The ampacity of a conductor is the maximum amount of current, in amps, that it can safely carry continuously without exceeding its temperature rating. The NEC specifies the ampacity of different wire sizes and types in Table 310.15b16. However, it is important to note that fixture wires often have different ampacity ratings than general-purpose wiring. Consult the specific wire manufacturer's specifications and the NEC for the correct ampacity rating for the number 16 TFFN fixture wire you are using. When connecting multiple light fixtures to the number 16 fixture wire, it is essential to calculate the total load. The total current drawn by all the fixtures must not exceed the ampacity of the number 16 fixture wire. Also, the total load in the 20-amp branch circuit, including all other loads connected to it, must not exceed 20 amps. Voltage drop is another important factor to consider. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, appliances to malfunction, and equipment to operate inefficiently. The NEC recommends limiting voltage drop on branch circuits to 3% for lighting, heating, and power loads, or 5% total voltage drop for feeders and branch circuits combined. To minimize voltage drop, use the shortest possible wire runs and ensure that the wire is properly sized for the load. In the example installation, the light fixtures should be spaced at intervals within the 100-foot limit. The spacing will depend on the type of fixtures, their wattage, and the desired level of illumination. It is important to distribute the load evenly along the fixture wire to prevent overloading any section of the wire. Regarding approved wiring methods, the NEC requires that all wiring be installed in a safe and workmanlike manner using approved wiring methods. This means that the number 16 fixture wires must be protected from physical damage and securely supported. Some common wiring methods for fixture wires include enclosing them in conduit, cable trays, or raceways. The specific wiring method will depend on the application and the environment in which the wiring is installed. While Article 240.5b2 allows for the use of number 16 fixture wire on a 20 amp circuit, it is important to remember that this is an exception to the general rule. In most cases, branch circuit conductors must be sized to match the overcurrent protection device, such as the circuit breaker. This means that a 20 amp circuit would typically require a number 12 AWG copper wire or number 10 AWG aluminum wire. The exception for fixture wires is allowed because they are used for a specific purpose, are limited in length, and are protected by the 20 amp circuit breaker. In addition to the NEC requirements, it is also important to follow all local codes and regulations. Local codes may have additional requirements or restrictions on the use of fixture wires. Always consult with a qualified electrician or electrical inspector to ensure that your installation complies with all applicable codes and regulations. Furthermore, when working with electricity, safety should always be the top priority. Always to energize the circuit before working on any wiring. Use proper safety equipment, such as insulated tools and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Improper wiring can be dangerous and can lead to electrical shock, fire, or equipment damage. Now let's dive into some more specifics regarding fixture wire. Fixture wire is designed for use in lighting fixtures and similar applications where flexibility and small size are important. It is typically made with stranded copper conductors and insulated with thermoplastic materials. The stranding provides flexibility, making it easier to route the wire through tight spaces and fixtures. The thermoplastic insulation provides electrical insulation and protection from environmental factors. Common types of fixture wire include TFN, TFFN, and THHN. TFN and TFFN are both thermoplastic fixture wires, but TFFN has a nylon jacket for added abrasion resistance. THHN is a thermoplastic high heat resistant nylon coated wire that is commonly used for general purpose wiring as well as fixture wiring. The NEC defines fixture wire in Article 402. This article covers the construction, installation, and use of fixture wire. It specifies the allowable uses, ampacity ratings, and other requirements for fixture wire. It's important to consult Article 402 to ensure that you are using the correct type of fixture wire for your application and that you are installing it properly. When tapping into branch circuit conductors with fixture wire, it is important to make a secure and reliable connection. Use approved connectors that are specifically designed for splicing wires. Wire connectors should be properly sized for the wire gauge and should be installed according to the manufacturer's instructions. Avoid using methods such as twisting the wires together and taping them, as these connections are not reliable and can lead to loose connections, overheating, and potential fire hazards. Another important consideration is the type of luminaires that are being connected to the fixture wire. Ensure that the luminaires are rated for the voltage and current of the circuit. Also, make sure that the luminaires are properly grounded to prevent electrical shock hazards. If the luminaires have exposed metal parts, they should be grounded using a grounding conductor that is connected to the building's grounding system. LED luminaires are becoming increasingly popular due to their energy efficiency and long lifespan. When using LED luminaires with fixture wire, it is important to consider their power consumption. LED luminaires typically draw less current than traditional incandescent or fluorescent luminaires, but it is still important to calculate the total load on the fixture wire to ensure that it does not exceed its ampacity rating. Furthermore, when installing fixture wire in damp or wet locations, use fixture wire that is specifically rated for those conditions. Wet location fixture wire is designed to withstand moisture and corrosion. It typically has a special insulation that is resistant to water and chemicals. Also, use waterproof connectors and fittings to prevent moisture from entering the wiring system. When running fixture wire through walls or ceilings, protect it from physical damage by using conduit or other approved wiring methods. This will prevent the wire from being damaged by nails, screws, or other objects. Also, avoid running fixture wire near sources of heat, such as recessed lighting fixtures, as this can cause the insulation to deteriorate over time. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector to ensure that your electrical installation is safe and complies with all applicable codes and regulations. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Now, let's delve into the significance of the 100-foot limitation mentioned in Article 240.5b2. This length restriction is primarily in place to mitigate voltage drop, as previously mentioned, but it also serves other crucial purposes related to safety and performance. Firstly, limiting the length of the number 16 fixture wire run helps to control the impedance of the circuit. Impedance is the total opposition to current flow in an alternating current circuit, and it includes resistance, inductive reactance, and capacitive reactance. Excessive impedance can cause voltage drop, reduce the efficiency of the circuit, and even lead to overheating of the conductors. By limiting the length of the fixture wire, the impedance is kept within acceptable limits. Secondly, the 100-foot limitation helps to minimize the risk of ground faults. A ground fault occurs when an ungrounded conductor comes into contact with a grounded surface, such as a metal enclosure or a grounding conductor. This can create a dangerous shock hazard and can also cause the circuit breaker to trip. By limiting the length of the fixture wire, the likelihood of a ground fault is reduced. Thirdly, the length limitation helps to prevent the spread of fire. If a short circuit or overload occurs in the fixture wire, the heat generated can ignite nearby combustible materials. By limiting the length of the wire, the amount of combustible material that can be ignited is reduced, thereby limiting the spread of fire. Fourthly, the 100-foot limitation is based on engineering calculations and testing. The NEC is developed by a committee of experts who consider various factors, such as the ampacity of the wire, the voltage drop, the impedance, and the potential for fire hazards. The 100-foot limitation is based on these calculations and testing to ensure that the installation is safe and reliable. Fifthly, it is crucial to understand that the 100-foot limitation applies to the total length of the fixture wire run, not just the distance between the tap and the last luminaire. This means that if the fixture wire is run in a loop or zigzag pattern, the total length of the wire must not exceed 100 feet. Also, the 100-foot limitation applies to each individual tap. If you have multiple taps on the same branch circuit, each tap must comply with the 100-foot limitation. Furthermore, the 100-foot limitation is not a suggestion, it is a requirement of the NEC. Failure to comply with this requirement can result in code violations, safety hazards, and potential liability. Always consult with a qualified electrician or electrical inspector to ensure that your installation complies with all applicable codes and regulations. Now, let's consider the impact of using different types of luminaires on the fixture wire installation. The type of luminaire can affect the ampacity requirements, the voltage drop, and the overall safety of the installation. Incandescent luminaires are the oldest and least efficient type of lighting. They produce light by heating a filament until it glows. Incandescent luminaires typically draw a significant amount of current and can generate a lot of heat. When using incandescent luminaires with fixture wire, it is important to carefully calculate the total load and ensure that the wire is adequately sized. Fluorescent luminaires are more energy efficient than incandescent luminaires. They produce light by passing an electric current through a gas-filled tube. Fluorescent luminaires typically draw less current than incandescent luminaires and generate less heat. However, they may require a ballast to regulate the current and voltage. LED luminaires are the most energy-efficient type of lighting currently available. They produce light by using light-emitting diodes. LED luminaires typically draw very little current and generate very little heat. They also have a very long lifespan. When using LED luminaires with fixture wire, it is important to ensure that they are compatible with the circuit voltage and that they are properly grounded. In addition to the type of luminaire, it is also important to consider the wattage of the luminaire. The wattage is a measure of the amount of power that the luminaire consumes. The higher the wattage, the more current the luminaire will draw. Ensure that the total wattage of all the luminaires connected to the fixture wire does not exceed the ampacity of the wire. Furthermore, it is important to consider the ambient temperature in the area where the fixture wire is installed. The ampacity of a conductor decreases as the ambient temperature increases. If the fixture wire is installed in a hot environment, it may be necessary to derate the ampacity of the wire. Derating means reducing the allowable current carrying capacity of the wire to account for the higher ambient temperature. The NEC provides tables that specify the derating factors for different ambient temperatures. Always consult these tables to ensure that you are using the correct ampacity rating for the fixture wire.